living in a black hole is probably not going to be super conducive to podcasts.
Yeah, not great.
Yeah.
Good thing we don't live in a black hole, eh?
Yet. Welcome to Dead Planet Society, a new scientist podcast. I'm Leah Crane.
And I'm Chelsea White. And today, we're going back in time, astronomically speaking.
Before about the 1600s, the scientific consensus was that Earth was at the center of the solar system.
Yeah, that's why Galileo was imprisoned. He was promoting the idea that Earth orbited the sun.
The idea had been around for a long time, centuries, but it was Copernicus who popularized it in the Renaissance.
Well, I mean, you say popularized. It was pretty unpopular.
Yeah, it could be pretty bad for you if you went around yelling about how the sun was the center of things.
That didn't stop Galileo, though, did it? He was considered a heretic for his views, and he was sentenced to house arrest. He did later recant.
Well, he officially recanted for reasons of not wanting to get executed.
Sure. But the reports from the end of his imprisonment suggest that he still believed. A book from 1757 says, "The moment he was set at liberty, he looked up to the sky and down to the ground, and stamping with his foot in a contemplative mood, he said, Eppure si muove."
That means, and yet it moves. He still believed that the Earth moved, orbiting the sun, and he was right.
Keyword was.
Sorry, Galileo, we are undoing it all today. It's time to bring back geocentrism.
You know, Earth is great, and the sun is mediocre at best. So let's get everything orbiting us instead of the sun.
For a little help, we talked to Andy Rivkin at Johns Hopkins University, who also joined us last season when we made the asteroid gong to save Earth from space rocks smashing into us.
That's right, he's back, and he told us that tinkering with the solar system like this could have ripple effects that reach even to Alpha Centauri, the next stellar system.
We're going to make Earth so big, we're going to make all the planets so fast, and we're going to mess with the whole neighborhood. Let's go!
Hi, Andy. Welcome back to Dead Planet Society.
Hi, Chelsea. It's a pleasure to be here.
Let's destroy the solar system.
Always.
What? Well, yeah, what else is new?
Right?
We're doing our thing. This episode, we're going to be talking about bringing back geocentrism because, frankly, we should be the center of everything.
Or, frankly, we want to know how much, destruction we can make if we're the center of everything.
No, Earth is the best planet. We're putting it at the middle.
You might get both.
Yeah, exactly. So my first question is, obviously this is impossible, but if we had a switch where we could just snap and Earth is the center of the solar system and everything, we're basically changing everything's orbits but leaving them as they are, what happens? I imagine some real terrible destruction happens right away.
Yes, indeed. So the first question, right, would be, how much would the mass of the Earth need to change in order to do that if we're going to have that piece of physics remain intact? So you first have to have the Earth big enough that the other planets stop paying attention to the sun and start paying attention to Earth.
Right, because if we just put everything on an orbit around Earth and left it as is, it would just rush back toward the sun, right? Like it just wouldn't stay at all.
Yeah, it wouldn't even, basically we could say, trivially, we could be like, hey, it's the 1400s again. We're just the middle. Just do your math like we're the middle. And actually, for most people, it probably wouldn't matter much because, if you ignore, Mercury and Venus, which a lot of people do, honestly, then everything is kind of far enough away that you kind of fake it. That's why for a long time, people did think the Earth was the center of the solar system. Mm-hmm. So if you want to do that and just change your math around a little bit and just say, well, we're going to change the origin point of our calculations from the sun to the Earth, you could kind of just mostly get away with it without changing anything. That's the least destructive option.
Skip the whole rigmarole. Just do math bad.
Just pretend, just say, from now on, we're just going to say that we're the middle. If you actually want to have it be where when you send spacecraft out and they do stuff, yeah, the way the math works out, everything's going to go around the most massive thing, or the most massive thing in the area is going to win, and that's still going to be the sun, unless you change the mass of the Earth.
Okay, so how do we change the mass of the Earth?
I mean, I think the question first is how much do we change it? And I suspect that's going to depend on if we want the sun to orbit the Earth also, or if we're just blipping away the sun.
I mean, I do want the sun to orbit the Earth. I would like light.
Yeah.
So, yeah, I think that's
So
that's
how
like
big does
crucial
Earth
to me.
have to be for the sun to orbit it?
So, if you set the sun and the Earth to be the same mass, which we're not going to do, but if you say, all right, that's what happens then they both kind of go around each other, go around a point kind of midway between them, as you might expect. Jupiter is something like 1,000 times less massive than the sun. So you could say, well, we'll have to make the Earth 1,000 times more massive than the sun. You could say that, look, we'll just make it 100 times more massive than the sun. 100 solar mass stars are out there. You're not asking for anything crazy from that point of view. But the trick is that once you kind of get over 2 to 3 solar masses, you kind of inevitably end up with a black hole. So unless you're a star yourself, and if you're a star yourself, you're eventually going to end up as a black hole.
So if we want to make Earth big enough to make the sun orbit it, we're going to ruin Earth, which is kind of not the point.
It's not. Oh.
I feel like we want to ruin everything else. Planet. But if we're not here, then who cares if we're the center?
Okay. So there's another piece of physics we need to suspend for the moment. Because living in a black hole is probably not going to be super conducive to podcasts.
Yeah, not great.
Yeah. So let's say that we can suspend that. Let's say that we can give Earth just a ton of mass, and we're going to somehow make it so it doesn't turn into a star or a black hole.
Yeah, I don't want to be a star either. Let's get that straight.
You're already a star, baby.
It's too late, Chelsea. You are a star. What are you talking about?
So I think maybe we suspend physics for just the case of making Earth big as hell.
Okay.
I do have a question about how we're doing suspending this physics, because are we just making Earth at its current size more massive, denser, or are we like ballooning up Earth to be large and maintain its density so it kind of still feels like Earth? Although, would it? It would not feel like Earth if it were that big.
Right. So the sun is 1,000,000 times more massive than the Earth. So to keep the same density, you'd need to increase the diameter of the Earth by 100.
Wow.
Right? Because 100 cubed is 1,000,000. I'm doing this on the fly, but I think I got that one. And in real physics, you'd still have a black hole because it would still just be, look, this is the mass in such a small area. I'm pretty sure that's true because even in that sense, you're still much smaller than the sun. Matter would not be able to keep itself at that size, at that mass. It would crush itself back down.
Would it affect the orbital dynamics at all? The decision of whether we keep Earth same size or if we balloon it?
The moon
do we
might
lose
be
the
unhappy.
Moon? Does the moon become like a nubbin?
Yeah, so if we increase the size of the Earth by 100, a factor of 100, that's out past the orbit of the moon.
Okay, so goodbye moon.
That would be no good. If you didn't get rid of the moon, but you made the Earth a solar mass, the moon would be whipping around kind of every hour.
Oh, this is incredible. Okay, let's do this one. I like that. Speed up the moon.
Fast moon.
Because the orbit period, right, all of these orbit things depend on the mass of the central body and the distance, and then something I'm sure we'll get to in a moment. You need a particular speed to maintain a circular orbit around a body of a certain mass. So assuming the moon doesn't, if we're saying that among other things, the moon also just suddenly gets that kick of speed when the Earth gets more massive, then it would be whipping around again every.
Because otherwise, it would just
hour and
just
change.
Fall in.
If you didn't give it that mass, it would just fall in.
Okay, so we've got race car moon. Does something happen to the moon if we speed it up like that? Does it like erode faster?
I think it will be well within the Roche limit of the Earth, although I admit I hadn't thought about this until now. So I think it's likely that the tidal forces, just because the gravity on the near end of the moon from the Earth, from giant Earth, versus the pull from on the backside of the moon from giant Earth are different. I think it would take the moon apart. Yeah.
Wow.
We'd have a ring.
Okay. I can live
that's
with
what
that.
I've always
I
wanted
think,
anyway.
Okay, so then what happens to the sun and the other planets? Do they have to speed up too?
They do. Otherwise, they will also just fall into the Earth.
Incredible. I love this.
Something like Jupiter would suddenly be going around 10 times faster, because the orbit period goes as the square root of the mass of the thing you're going around. So instead of a 12-year period, Jupiter would now be zinging around every 1.2 years if it gets the right speed. Otherwise, it'll not have enough speed to kind of make it, and it'll just start falling. Whether or not it clears the Earth and just becomes a super eccentric body or not will depend on the exact mass we give the Earth, and I suppose the exact size we give the Earth. But that will be true of every object out there, and the further out you go, the closer to standing still they are relative to the speed they need, I think. So yeah, we'd have kind of a parade in that first century or two of giant planets, of kind of everything, not just giant planets, every asteroid, every comet, everything. And the sun, if you don't give it the boost it needs, will just kind of come zinging past, and some of them will hit.
I'm just picturing, like, from Earth, like, all of the planets, like, coming at us. I didn't imagine this would be the case.
No, this would be, I guess it would be like the sequel to Moonfall, if someone wants to make a sequel to Moonfall or something.
Everything fall.
Everything fall. That's right.
Now we have a special offer for Dead Planet Society listeners. You can get a 10-week digital subscription for $10 or £10, which includes unlimited access to our website and app. To learn more, go to newscientist.com/DPS offer.
And if you enjoy our podcast, you might also enjoy my free monthly space newsletter at New Scientist, Launchpad. Check it out at newscientist.com/launchpad. And if you love eclipses, New Scientist Discovery Tours now has 2 new eclipse tours live on our website. One going to Greenland in 2026 and another sailing the Nile in 2027. Go to newscientist.com/tours to find out more.
So if we're doing this like in one single moment, does that mean that we've set off this kind of horse race? Would everybody get to us at the same time?
Tackle football.
Are we the finish line?
I think
Yeah.
all of this is, you could put the disclaimer, I think. So I think there are multiple things going on, right? Because right now, everything goes around the sun, right? So Venus goes, when Venus is closest to Earth, it's about the third the distance to the sun at its closest. But at its farthest, when it's on the other side of the sun, it's, 1.5 times, 1.7 times as far as the sun. Mars, when it's closest to us, is about half the distance to the sun. And when it's at its furthest on the other side of the sun, it's about 2.5 times. Depending on the moment you do it, Venus and Mars could show up at exactly the same time.
They could just smash into each other.
Or they might smash into each other on the way in. There's all sorts of things, because you're suddenly changing the point of the orbits, or the focus of the ellipse from over here to over here, and everything has to suddenly adjust. So it's going to be chaos.
So this, that's what we peddle in here.
I know.
So this makes me think about a question I had before when we were thinking about this originally, which was, how does the night sky change if everything is sort of orderly and processing around Earth? But now I'm thinking, are we going to have like a Jupiter coming at us in the night sky, just getting bigger and bigger and bigger? A la Moonfall?
Sure sounds like it.
but remember cosmic timescales. It's not going to probably appear to be coming at us.
Look, if I can make Earth like suddenly more massive, I'm immortal. I have powers.
Yeah, I mean, if you could also look at it this way, if the Earth, gets to be, even if the Earth is at 1 solar mass, and like we said, that's not going to cut it. But even if the Earth is 1 solar mass, then Jupiter is going to be going around every 12 years. And I think that's kind of the time scale. So if you suddenly make it 100 solar masses or whatever it is, and it's 1 year to go around an orbit, an orderly orbit. I think that also means that it's going to be a year-ish, 6 months-ish before it shows up. Because that's, the point. If it were a point mass, that would be the period of the new orbit is a year. So I think that's what's going on. And I will again caution anyone who's watching this. I'm an asteroid spectroscopist, but I think all of this is true anyway.
We're going to be able to do a lot of incredible science for like a month before we all die. Everything's going to be so close.
With what instruments? The instruments that have gotten swallowed up in the black hole we've created of the Earth, or I guess not, but all the satellites we've made, JWST is going to be one of our first arrivals, right?
Yeah, fair. We're going to find out if Jupiter has a core, and we're going to find out by smashing into it.
But then that makes me question, like, what if, in addition to this, we took the sun, like if we could like just pick it up with a big claw machine and move it out further, maybe even beyond Pluto. I'm sure it would be dim here, but if we could get the sun to the outer edges and then get everybody going around us, could there be equilibrium? Would we still need to be that big?
Well, the Earth, if you remove the sun from the system and you say, okay, we're going to magically still have enough light and heat and whatever,
sure, then
everything's going to want to go around Jupiter.
Oh.
Or the Jupiter and Saturn will kind of sort it out, and then we'll be kind of going around them. So that's the thing, is the biggest, most massive thing wins. So we would have to both remove the sun to a safe distance and make ourselves a solar mass. If we went for a true reordering and either decided to, things are kind of at awkward distances from one another. So the sun would be at its current distance, say. If we put Mars at its current distance from the sun, except put it around the Earth instead at that distance, then it's going to be getting pretty darn close to the sun sometimes. You've got to figure out what to do with Venus and Mercury. If one could get around some of these complications that we've talked about, I think removing the sun from the area, you still need to make the Earth big. So you need to get around. You need to get around that. You need to accept that.
Okay. Well, then
you're in
there's
bargaining.
no point.
You're in bargaining. You need to get to
acceptance.
I'm coming to full acceptance, which I think means the sun's got to stay because, But that also makes me question what happens for the moments that we are stable, for the 6 months or whatever, until everything kills us.
For the day and a half before we die.
There's Earth, there's a few planets, then there's the sun, then there's the outer planets.
Don't forget all the asteroids.
Sure, but what I'm wondering is...
Set up the gong. We can set up the gong for that. That'll be
Bring
perfect.
back the asteroid gong. I'm wondering if the outer planets, like the ice giants, if they melt, if they get more habitable. If
Briefly.
There's anything in there. I don't know what's in there.
They are going to have atmospheric loss for sure.
Yeah.
We're creating a whole new comet population. Do you think the night sky would be crazy? I feel like we make sort of a lot of noise about comets when you can see them in the night sky and they're very beautiful. And if suddenly everything's a comet... And also, all the planets are moving differently with respect to us. It seems like it would be very different.
Yeah, well, I mean, the moon alone is going
Forgot about the moon.
Really freak everyone out, basically. It's going to be it's going to be, hey, look at the moon. Hey, what? Assuming, I don't know if you're going to warn people that you're going to do this before you do it, or if it's just suddenly going to,
They'd probably try to stop us.
Then, probably. So yeah, the moon would probably be the first thing. It's like, hey, the moon I can see the moon moving in the sky. That's really seems like that's bad. Followed by hey, it seems like it's breaking up in its orbit. That also seems really bad. I guess there's potentially some question of, you could take this in the direction of how would people figure it out if you did it and didn't tell anyone. I think the moon would be the tell.
Yeah.
It's a bird. It's a plane. It was the moon.
Exactly. But that actually reminds me, because I was thinking, if the sun is going around us, functionally, will I notice any difference in the day-night cycle, anything about the light that would be different? I don't know that I would, but I would notice if the moon exploded.
Presumably.
Yeah, I think the sun would basically, it sounds like what we've been talking about for this latter this part of the discussion is we wouldn't notice anything particularly. No. I think another interesting piece, maybe because I am an asteroid spectroscopist, is that all of the orbits of the asteroids would be funny. It's, when there's only there's 8 planets or 9 planets or however many planets you feel like, that's a number that you can kind of go, oh, sure, you could just sort it out and it'll be fine. You put them at their current distances. But I feel like, there's a lot of asteroids that come close to Earth already, and figuring them out might be a bit more of a challenge if all of a sudden, again, all the orbital calculations change, right?
I mean, we've also made Earth a much bigger target. So yeah.
Yeah, no, that's true.
And you can't, like Chelsea, you were saying earlier with the cosmic claw machine, you can't really do the asteroids like that. Although last season we did turn all the asteroids into one planet. So if we could do that, it might make life easier.
Step 1, asteroid planet. Step 2.
Step 1, gong. Step 2, asteroid planet.
Step 3, Terra system.
That's right, the terror system.
The terror system, yeah.
It looks like basically what we're going to do is everything's probably going to smash together and smash up, and then we're going to ruin everything. But that's par for the course, right?
And the night sky might look okay for a minute.
Yeah, if you play your cards right and you make, if you go for the 100 solar mass option, you might even start to kind of make Alpha Centauri uncomfortable. So
wait, say more about that. Why?
Well, because things are moving around the galaxy, right? I mean, the solar system is part of a galaxy of stars. They're all moving around and just like everything else, if, Alpha Centauri and the sun are about the same mass, it's a triple system, but, they're about the same mass, and they're moving, kind of past each other, doing whatever, 4 light years apart from each other. That's plenty big if you've got 2 things that are one solar mass, right? But if you suddenly, here's a thing that's 100 times the mass of the sun, I'm not saying that Alpha Centauri is going to come screaming in and hit us, but seems like it would absolutely affect the stars, the paths of the nearby stars at some level.
Seems also bad.
Again,
but also kind of incredible. I didn't think our powers extended that far. Thank you all for joining us for Dead Planet Society. If you want to catch up on previous episodes, head over to newscientist.com/deadplanets. We've got a lot of great things coming up for you. Look forward to new episodes every other Tuesday right here in the New Scientist feed.
A listener, Dean, wrote in to ask if we could delay the sun's inevitable demise by feeding it extra hydrogen to burn instead of moving on to heavier elements and eventually blowing up.
Stopping the sun from blowing up? That's not usually in our wheelhouse, but maybe we'll give it a go for you, Dean.
And if anyone else out there has a cosmic object you want us to figure out how to destroy, not to save Dean, let us know, and it could be featured in a later episode of the podcast. Our email is deadplanets@newscientist.com.
Bye. For whatever havoc we're going to wreak, we're going to get some beautiful night skies sometimes, which seems worth it to me.
Briefly.